Hey, welcome back. So I figured I'm going to do a little semi-project video between Christmas and New Year, and I had a bit of a problem that I tried to solve for quite some time, and that's lubrication on machine tools. It's in the industry, it's a solved problem. You go to Vogel or Lincoln and buy one-shot lubricator systems. You buy the pump, you buy the distributor blocks, and you buy all the fittings and hoses and everything you need right out of the catalog. And it's a no-brainer. We as humans have solved these problems a few years ago quite well. There is still new things that come, but the basic needs of lubricating machine tools is solved, but it's expensive. The cheapest manual pump for oil from Lincoln is like 350 euros. And it's just a clear plastic container with a lever pump to move oil into the distributor blocks. And for a real business, that's not a problem. Yeah, it's almost free at that point. But if you're a penny pincher or a hobbyist or both, this is quite a bit of money. That's like 50 doner kebabs. So I figured, let's take one of these grease gun, the greasy type, not the M3 type of grease gun. And I looked at it and I figured if you take this, and it's a pump. It's basically a very simple single-acting piston pump in here with a hose and a container. It has this spring-loaded mechanism here, which this one isn't spring-loaded anymore. It should be spring-loaded. That's funny. Okay. Anyways, I figured I'd take one of these and I modified it into a one-shot oiler pump. There are cheap systems, of course. You can go to AliExpress and buy a pump for, I think, like 20 euros. But if we have the option to not ship crap around half the world, well, I think that's a good opportunity to invent something yourself and come up with a solution that you like yourself. So I purchased a new one of these pumps, of these grease guns. These are made by Mato here in Germany, and they cost like 20 to 30 euros. It's quite affordable for a made in Germany item. And this is what I came up with. This is the El Cheapo one-shot oiler pump. Let's look at the modifications I did. Took a standard grease gun like this, and the end, there is this spring-loaded, there is this plunger in it that forces the grease under spring pressure into the pump. We don't need that because we're running oil and we can rely on gravity to gravitate the oil into the pump. So I took this apart and I forgot that the spring in these is pre-tensioned, so this flew across half the shop. Once I undid the nut that holds the piston to this rod, made a quite funny noise. And I took a bandsaw and I sawed off the rear end because this is all crimped together and kind of one piece and not easy to take apart. So bandsaw, took it off, deburred the end of the container here. Boink. And also I cut down the handle because this is way too long for the purpose. These grease guns are supposed to build a pressure of 400 to 800 bars. That's a lot of PSIs. And I figured, well, half the handle length is still fine and I don't need the pressure. And this is quite the travel, quite the distance to move the handle. With a shorter handle, the distance to move gets shorter, of course. So I hacksawed it off and I 3D printed a new knob that just presses onto the sheet metal. And it kind of looks, I like how it looks. Then there usually is a filler port in the end of this cap here. I unscrewed it because it's like a check valve and it tends to leak with oil, I found out. So I put in a blind screw and I undid the braided hose from for the grease. And I just put in a 90-degree fitting and a 6mm pneumatic hose fitting, push-in fitting from Telemechanique. And that's all the modifications I had to do. Oh, and of all places where this thing can leak, it leaked in the thread between the pump body and the container here. But that was easy to be solved with Teflon tape. So that's all the modifications that were necessary to make this into a quite nice one-shot pump. Let's put it on the decal milling machine and talk about my intent with this. Okay, we're over at the decal milling machine and I wanted to show you the lubrication situation on these machines. For these machines up to a certain age, you had to manually use a oil gun to lubricate them. On the vertical saddle, they have one circ fitting, and that's doing all the lubrication for the X and C axis, both at one time. You fill an interior reservoir with oil, then there are oil passages and oil wicks that get the oil, hopefully, to where it belongs, as long as nobody put grease into there. Just because it's a circ fitting, it does not mean that it's for grease. It's a lubrication fitting, not a grease fitting. What goes in there is always set by the manual of the machine, by the manufacturer. He says oil or grease or something else. And on most machine tools, most circ fittings are for oil. And if somebody puts grease in here, you have a problem because you have to take apart everything and clean out the grease. So careful with used decal milling machines. Either make sure they were never lubricated with grease or take them apart. But basically, you have the circ fitting, and above it is a oil glass, a sight glass with a hole. And you just take your oiler. This is one of these pump oilers. And you go here and you pump oil into the reservoir. And at some point, the sight glass has a small hole into it. And at some point, it will squeeze out oil at the top. So you don't have to look at the sight glass. You can do this from kind of the front of the machine. But this is kind of an annoying process because the amount of oil that comes out of these oil guns is not very much per pump. And then they are empty and you have to fill them and it's just a mess. Ah, there it is. Now it squeezes oil over the top. That means that the reservoir is filled and we can start working. That's always a little bit of a workout right at the start of when you start your day. So yeah, let's optimize the situation. Take this fitting here. I loosened this earlier. It's just hand tightened in there. So let's undo this. There's a plastic seal and there's an M8x1 thread in it, in the casting here. And here's one I prepared earlier. I took a 6mm right angle fitting for 6mm hose with an M5 thread, and I took a standard circ fitting, parted it off, tapped the inside M5, and then I screwed this elbow into this fitting. So I made this fitting here M8 by 1. Added an O-ring here, and now this screws in here. And you can tighten it down. Doesn't need much torque. The oil ring provides adequate sealing. So you put this in here, and then I have a 6mm pneumatic hose that can go right in here. And this is routed out to the back of the machine. I 3D printed a bracket, two-part bracket out of PLA that holds my modified grease gun, now one-shot oiler, to the arm that mounts my DRO. And because I was super sloppy when I removed the support structure, the 3D print cracked here. Great. I will reprint it, but that's the mount for it. Very solid. Cap goes on here. Well, we need some oil in there. That's whey oil. Oh, that's fine. And we can put the cover on so we don't get any dirt into the container. Shouldn't be in the way back there. And the hose that's connecting to the saddle, to the fitting on the saddle that I just showed, is routed through the back of the machine, and it goes into the underside of the pump here. And there we go. So let's look here at the hose. It's currently not filled with oil, or only partially filled. Let's give it a few pumps. 1, 2, 3, and there already is oil coming out. There is still some air bubbles in the system. And yeah, the oil is dribbling down all the machine, but that's not a problem. Too much oil never killed a machine. Well, not a milling machine at least. Your high vacuum apparatus might be unhappy about a generous amount of oil. But that's different industry. But yeah. I think I got all the air out of the system. Maybe a check valve in here might be a good idea, but it shouldn't go back through the piston pump in the former grease gun. So you just give it a 1 or 2 pumps until everything is primed, until the reservoir is filled, and you're good to go. And the container is very generous. I think this is almost like half a liter. I plan to do the same for the lathe, but this will be a little bit more of a project because the lathe has 6 or 8 lubrication points that need oil individually. And you cannot just tee off, use a T fitting and splice off oil, because the oil will always go to the lubrication spot that gives the least resistance to oil. Some quick theory, because I think I wasn't able to tell this correctly. Let's say you have a machine tool like this stylized Deckel FP1 mill here and it has only one lubrication spot. Let's say this here is the lubrication spot, and you have a pump over here with lever, and the pump has one output. There is no problem in just running a line from the pump to the single lubrication spot, but you get into trouble as soon as let's say there are 2 lubrication spots on the y-axis. This one here stays, and maybe one down here for a weird gearbox, and one in front here that's dripping oil onto on the C lead screw. Doesn't matter. And you cannot just do this. You cannot just T-branch all of this into each other, because, for example, the y-axis ways would require quite the high pressure to squeeze the oil into lubrication channels. But down here you have just oil going out of the fitting and dribbling onto a lead screw, for example. This takes virtually zero pressure to work. So the oil will always go the path of least resistance. So like 99% of oil would just run into here and then go into the sump of the machine. And these up here, and maybe the gearbox and this one here, would all stay dry, despite you thinking, oh yeah, I have a one-shot oiler and I'm pumping like like a madman, and I put in 250 milliliters of oil each time I start the day. But in reality, you're starving all these oil points, but wasting all the oil into the sump. So industry knows this, of course. So, and in those cases, you have a pump, and you go out with a single line into a distributor block. And these, there are different kinds. There are metering valves, there are piston types, and there are fixed volume distributors, progressive blocks that output, for example, 6 lines. And in the most simple case, it just divides the amount of oil that comes into this line, 1 divided by 6. And then you have 1/6 of the oil coming out each of the lines. And you can run those to the machine tool, to your individual lubrication spots. Now you might say, well, 1/6 of the oil of one pump stroke is not enough to lubricate the ways. Yeah, you just pump twice or more times until you see oil coming out of the sides of slideway, for example. Or you have an electric pump that runs off a timer. That's kind of common on higher end machines. And then you have your funny comic milling machine over here, a table, and you can run this to the y-axis. This goes to the y-axis, this goes to the c-axis screw, this goes to c-axis guideways, gearbox, and this one, well, maybe you don't only need 5. Then depending on the type of distributor blocks, you can either route the last one back into the tank, or you can connect 2 of the outputs. That does not work with all types of oil distributor blocks. The progressive blocks have very strict ways of doing this. You can put 2 together and double basically the oil amount that the lubrication spot gets per pump. So that was a super quick rundown. So don't simply T-branch off the oil. That's absolutely not a good solution. But there is another solution that you can do if you have a machine tool. Let's draw a lathe. Headstock, bed, carriage with the it's the compound. Here is the hand wheel for the cross slide, and here is a carriage hand wheel. And we have tailstock here too. Let's say this has 3 oil spots in front here, 1 to the back side of the carriage, which is really hard to reach, 2 on the compound slide, 1 here on the tailstock lubricating the ram, and maybe well, you have the lead screw here and you have a bearing block here, maybe 1 here. And finding each of these lubricating spots each time is really annoying. So one thing that you can do, you can route all of these all of these oil spots into a distributor block and just have individual circ fittings out here. Like this, and just connect them straight through. This can simply be an aluminum block with some threaded holes. And so on. And you do this with all of them. Like this. And you still have to lubricate each spot by hand with the oil gun. But they are all in one spot and you don't have to climb across the machine and do the funny dance around the machine trying to reach the circ fitting on the backside. So this is an alternative. This is a compromise solution out of manual lubricating with a oil gun and having a full-blown one-shot oiler system with distributor. So many ways to solve this problem, but I have seen this even on the industrial machines where all the oil spots were routed to a central block and you just ran your oil gun on each of them. Worked quite well. And I think I said it before, but oil is cheap, machines are expensive. If you over-lubricate, it does not really matter in most cases. In some cases you might not want to over-lubricate. Woodworking machines could be an example, but metalworking machines, oil is great. Oil is lubricating, it's flushing out crap from the slideways. It's great. Oil is good. I hope you enjoyed this show and tell about a project that solves a already solved problem. Again, just not as good. But my idea behind this was to go for a solution that's neither the expensive industrial solution, which for a penny pincher is a lot of money, or the AliExpress solution, which needs to be shipped around half the world. Maybe, well, the thing is I like to make stuff. I like to come up with solutions with off-the-shelf items and modify them to my needs. And this is another one of these cases. I will see how it holds up. Happy holidays! Depending on if you celebrate, if you don't celebrate with family, friends or alone. Just make the best of these days. Thank you all for watching, thanks for the support, and we'll probably see you next year.